time. So without delaying, let us get into our third day for our reservoir engineering session. So last sessions we have discussed about drive mechanisms, the properties of reservoir rock as well as reservoir fluid properties. Like we have discussed about porosity, permeability, and capillary pressure, wettability. So like these things we have discussed for rock properties. When it comes to fluid properties, we have discussed about formation volume factor, uh, viscosity of the fluid, density, and solution gas. Uh, Apart from this, we have discussed something more related to drive mechanisms, how the drive mechanisms will uh, help to produce oil towards your production well without application of any other force. Drive mechanisms itself will help you to produce oil towards your production well. So let us get into some more topics. So how to estimate oil in place? So this is one among reserve estimation technique. We have like four different kinds of reserve estimation techniques are there. One is volumetric, material balance, production decline curve, and reservoir simulation. So today we are going to discuss about volumetric way of estimating oil in place. In place represents in situ conditions, like during before production, how much amount of reserves have been present inside the reservoir that we are going to estimate through this formula. N represents amount of reserves present inside the reservoir and which is related to oil. So that will be equivalent to 7758 into area of the reservoir into thickness, that is H, into phi represents porosity, 1 minus SWI. We have discussed about connate water saturation, which has a synonym of interstitial water saturation or initial water saturation. Anything may come under this SWI by BOI. BOI represents formation volume factor of oil at initial conditions. So when we are writing I represents initial conditions, means before production, the amount of oil present inside the reservoir that will be estimated as N. So there is another word called NP. NP means production oil, like how much amount of oil have been produced. In that way, in place of the formula will be same, area will be same, H will be same, porosity, these are all constants at any kind of production. This will not change. 1 minus SWI, that also will be considered to be constant. Why? Because this water is a part of rock. It is integral part of rock. It cannot be recovered. So only the one which is going to be changed is BOI will become BO, simply BO. So BO represents formation volume factor of oil at production conditions. Production means the time at any time once after starting production. Like before production, it will be BOI. After production, it will be simply BO. Okay, this is how we are going to estimate oil in place through volumetrically, and the numerical 7758 was given over here only for the purpose of converting. When the area was given in acres, like if you could observe here, if it is given in acres, you have to convert into barrels. So acres to barrels, 1 acre is equal to 7758 barrels. So in that way, we have adjusted that value over here. So let us go for the calculation of gas in place. So gas in place formula is also the same, almost 43,560 area of the reservoir into thickness, that is H, into porosity, into 1 minus SWI by BGI. So here BG represents formation volume factor of gas, I represents initial conditions. So again, we are measuring G, that is before production. That is the reason we are putting it BGI. If we have to put it during production time, then you have to put it simply BG. Okay, so that is how we are going to calculate. And the same, that numerical value 43,560 was given to convert areas to standard cubic feet. Here gas units will be measured with respect to standard cubic feet. So if area was given in acres, we have to convert acre to standard cubic feet. So the formula for that one is 1 acre is equal to 43,560. For that convention adjustment, we have given that value. So when it comes to production of gas, GP, so here we are going to see some changes in the formula. 43,560 AH5, that will not change. GP represents amount of gas produced. Like at initial conditions, we are going to measure gas as G. During production conditions, we are going to measure gas as GP. So GP represents amount of gas at produced condition. So during production, so the formula will be altering like this: 43,560, the same way like earlier how we have calculated for G, A into H into phi into 1 minus SWI into 1 by BGI minus 1 by BGA. BGI is the one we are going to calculate before production. Before gas started to produce into well, what is the formation volume factor of gas is BGI. Once you start to produce, here the thing is like it was given as BGA, formation volume factor of gas at abandonment condition. Abandonment means complete production have been ceased off. So before completely complete production, what is the amount of formation volume factor of gas? So this is not starting of production, this is end of production. So during the end of production, what is the value of formation volume factor of gas? That is BGA. Starting of production will be, you can take it as BG. At the end of production, you can take it as BGA. So at the end of production of gas completely, the formation volume factor of gas, if it is measured at that condition, that will be having the value of BGA. So if you know the value of BGI and BGA, then you can able to calculate with other values, you can able to calculate gas at produced condition. So next topic, we are going to discuss about flow regimes. So we have three types of flow regimes will be observed mostly inside your reservoir, and they follow a sequence. So we have three types of flow mechanisms are there. One is steady state flow, pseudo steady state flow, and unsteady state or transient flow. So how these flow regimes will be understood? What are the conditions to be understood, and what are the kind of symptoms you can observe inside the well? So first thing is, let us discuss about steady state flow. Steady state represents linear flow, something like which is coming constant, like it is happening in a constant way. So steady state, which is linear. So the condition for steady state flow is dou P by dou T is equal to 0. That represents dou P, change in pressure, with respect to dou T, change in time. So change in pressure with respect to time is equal to 0. That represents when you change time. Let us measure pressure at different locations during steady state flow. Let us measure pressure at different locations inside the reservoir. Imagine a reservoir. You are measuring pressure at point A, point B, point C, or different xi, x1, x2, x3, like three different locations are there. You are measuring pressure. So when you have measured pressure at time t1, let us think that x1 has given you 1600 psi, x2 has given you 1400 psi, and x3 have given you 1300 psi. When you change time, when time progresses, like t1 become t2 after 1 hour, t2 become t3, like that, if you progressively passing through the time, like t1 become t2, t2 to t3, t2 to t4. So if you measure pressure at any time level, either at a t1 or t10 or t15, these x1 values and x2 and x3 values will never change. That means at t1 the value of x1 is 1600, t2 will t2 also the value of x1 will be 1600, and t3 also the value will be 1600. In that way it will never change. So if it is not changing, then the pressure is represented to be constant. So dou by dou T of pressure, which is constant, that can be taken as 0. Dou by dou T of constant is equal to 0. So here the pressure is constant. If you change time, but if you observe pressure with respect to time, it is not changing. So it is showing to be constant. At any time you take, the pressure is represented to be constant. In that way, dou P by dou T can be given as 0. Why? Because dou by dou T of P which is constant. So dou by dou t of constant is equal to 0. When it comes to pseudo steady state flow, the same example, you have taken x1 as 1600, x2 as 1500, and x3 as 1400. So right now, let us change time from t1 to t2, t2 to t3, like that. 1 hour time gap is there between every time level. So let us calculate time at t1. So x1 is showing you 1600 psi. When it comes to T2, it will not be 1600 psi. Probably it will be 1550 psi. 10 psi have been reduced. When it comes to T3, 1550 have become 1590, sorry. Why? Because 10 psi out of 1600 will be 1590. So from 1590, it became 1580. At each time level, 10 psi reduction of pressure is been observed at one particular location. Let us take that location to be xi. So when you measure at the time T1, it is 1600 psi. When you go for time T2, it is becoming 1590. When you go to time T3, it is becoming 1580. So when you are progressing towards time, you start observing that the pressure at that location started to reduce constantly with 10 psi. So that means what? Change in pressure is constant. Here the thing is like dou by dou t of P, which is changing with respect to time. So P is not a constant, it is a variable. This variable is also changing in a constant way. How it is changing? So dou P means represents change in pressure. So that itself is constant. So dou P by dou T is equal to constant. Why? Because here the P, which is not a constant, it is a variable, but it is changing in a constant way. So what is the change is constant. So change in pressure, that is dou P, with respect to change in time, that is dou T, that is equal to constant. When you change time, pressure is changing, that too in a constant way. So in that way, this condition is applied for pseudo steady state flow. When it comes to unsteady state flow, or the other name for unsteady state flow is transient flow, change in pressure with respect to change in time, either it is not constant, neither it is a variable. How it will? It is dependent on location and time. So the pressure with respect to time is a dependent on location, that is I, and respect to time. When you change, when you keep location constant, when you change time, pressure will change. If you change, if you keep time constant, when you change location, then pressure also will change. So this is how this equation can be understood. Dou P by dou T is equal to F of IT. Dou P by dou T means change in pressure with respect to change in time is a function of I represents location and T represents time. So this is how we are going to measure unsteady state flow. So change in pressure with respect to change in time is a function of location and time. So before getting into this little deeply, I would like to tell you how chronologically it will be arranged. So first, expected flow will be steady or pseudo steady or unsteady. That we have to identify how it will be happening. Like first of all, we are going to drill a well and then start perforating it so that fluid will start to flow into the well from the reservoir. Pressure change will happen. So because of that, fluid will start to flow into the well. So immediately, once you start to observe flow which is happening into well, the first flow you will start to witness is unsteady state flow. Unsteady state flow is the first flow which will happen immediately after opening the perforations. Then comes steady state flow. Then finally pseudo steady state flow. So chronologically, if you could observe, once you started to drill a well, then you perforate it, then fluid flow will happen into the well, then immediately you will witness to see first flow mechanism, that is unsteady state flow. Then comes steady state flow. And finally, your well will end with pseudo steady state flow. And the time level of unsteady state flow will be uh, a reasonable amount of time, probably 6 months, 7 months, something like that. When it comes to next step, that is steady state flow, this will be having a shorter period. So compared to pseudo steady and unsteady, the shortest one is steady state flow, and the longest time duration phase is pseudo steady state flow. So pseudo steady state flow is the declination phase where the pressure reduction is observed to be constant, and that will be continued for long term, where secondary production like water flooding and enhanced oil recovery will be observed in pseudo steady state flow. Steady state flow where water drive mechanism is acting, because of that that fluid flow is to be as a steady state flow. When it comes to unsteady state flow, irrespective of any kind of drive mechanisms or artificial techniques, automatically immediately after drilling a well, you can witness unsteady state, which will happen immediately. Naturally itself, you open the well, you open the perforation, so fluid flow is expected to flow into the oil, so that there will be a disturbance, turbulence, or some kind of random disturbance will happen near to the perforations. In that way, unsteady state flow will be generated. Then steady state flow will happen with water drive mechanism. It depends on the pool, how much amount of water is there, how it is pressurizing oil water contact, so that it can maintain reservoir pressure. Until it is maintained, steady state flow can be witnessed. Once after that reservoir pressure starts to get declined, then you can start witnessing pseudo steady state flow, and this will be maintained by secondary flooding, that is water flooding or else gas flooding, and comes enhanced oil recovery, where you can witness that pressure drop will happen. Okay, let us go into deeply how this pressure disturbance will happen, so that you can able to witness unsteady state flow. First condition is unsteady state flow. You know that I already told you the condition for unsteady state flow is change in pressure with respect to change in time is dependent as a function of I and T. I represents location and T represents time. Okay, so here you can witness flow rate is constant. This is the symptom. Actually, when unsteady state flow is happening, you can witness fluid is flowing constantly into the well. And if you could observe, like today you are getting around 200 barrels, tomorrow also it will be the same 200 barrels. So why? Because your well is having that capacity, it may not be more. It is the maximum capacity to produce oil, that is 200 barrels. Imagine if it is happening for one particular well which is having 200 barrels capacity, so it will produce 200 barrels today, tomorrow, day after tomorrow, until the end of unsteady state flow. The flow rate is observed to be constant. Then how this unsteady state flow can be observed, like how you can see, imagine if you have a reservoir, like how to be observed. Let us imagine a drop of, imagine there is a pond of water is there. uh, if you throw a stone in a pond of water, you can able to observe some kind of ripples. So these ripples will be generated near to the stone where it is touching the surface. So immediately you can witness one particular ripple will be generated immediately once the stone touches the surface. Then after that, this ripple will progress further. Then second ripple will be generated at that point. After some time, the second ripple also will go further and third ripple will be generated. So like that, these ripples will be generated simultaneously until the first ripple reaches the boundary of that particular pond. So once it reaches to that particular point, there won't be any new ripples that will be generated. Whatever ripples are there, that will stay for some time. After that, it will saturate. You cannot able to see much ripples at that time. So this is how it will happen. You can understand when a stone was thrown into a plain pond where the water is plain, there is no turbulence or any movement of waves are there. So imagine that water is plain. You have thrown a stone over there. So once the stone touches the surface of water, it will start to generate first ripple. Once it is generated, this ripple will start to progress further towards the end of the boundary. While it is moving further, second ripple will be generated at that point. After that, the second ripple will move forward and third ripple will be generated. So like that, third ripple have generated and it is moving further, fourth ripple will be generated. So like that, one by one ripples will start to generate near the stone where it has touched the surface. You have to see where the first ripple has, that first ripple started from the stone surface, it started to move and it has reached after some time and it touched the outer boundary. So it took some time. The first ripple started from surface where the stone touched the water and it started to move from there, and finally it took some time to reach to the outer boundary. So if you collect the flow rate of this water during the travel of first ripple from the stone surface to the end of the pond, that flow rate is considered to be unsteady state flow rate. So the condition here is the first ripple started and it started to move further towards the end of the boundary. It took some time. So this time is known to be transient time. Transient time means the time taken to travel that first ripple to reach the boundary of the pond. So during this travel, if you start collecting water, like in our example, I'm telling water, probably if the same thing happens inside our oil reservoir, you are collecting oil. So if you start to collect oil during that particular time where the first ripple started to move from well and until it reaches the outside of your boundary, that particular time period is considered to be unsteady state flow. Once this ripple touches to the outer boundary, all the ripples have been generated one by one before this first ripple. So that will stay static for some time. That is considered to be steady state flow. Then after that, these ripples will start to saturate. Then this saturated time is considered to be pseudo steady state flow. Okay, this is how we can contextualize how this unsteady state flow and steady state and pseudo steady can be understood in reservoir. Right now, I will try to simulate it directly with the reservoir, try to understand. So let us think that we have different layers and already there is a reservoir, which is the pressure have been already measured near the boundary. The pressure was observed to be 2000 psi. So let us think that we have drilled a well. So right now the thing is like drilled a well means imagine this reservoir to be a plain pond. There is no disturbance everywhere. The pressure is constant. There is no disturbance at all. So right now drilling well represents throwing stone. Like our earlier example, we have thrown a stone. So you perforated it. You have perforated it. Once you start perforation, then the pressure disturbance start to create. Like the stone has entered into the surface of water, creating first ripple. So first ripple have been created. So when you create this first ripple, that means what? You started to produce some amount of oil into well. That means pressure started to reduce. Before this green ripple, the pressure in that location, in the location where you have measured pressure, before this green ripple, it was 2000 psi. Once you have created this ripple, from 2000 psi, it has reduced to 1900 psi. So this happened at T1. This happened at one particular time, that is T1. Then after some more time, this pressure disturbance will move forward. So this this green ripple have become dark blue ripple. So that means 1900 psi have progressed further, and the location where earlier it is 1900 became 1800. Means pressure started to reduce at that location. So earlier it is 2000, then comes 1900, and right now it became 1800. And this 1900 which was created, that earlier ripple, have progressed little further. Why? Because you have progressed in time. So you are changing time here, like you are progressing further. When you are progressing further, automatically pressure started to get reduced at that location and it is moving forward. So let us go for the next time level. If you could observe over here, this green level time has this green level where the location earlier we have measured is 1900 became 1700, and the blue one, it was became from 1900 it became 1800, and earlier here it is 2000. This 1900 and moved to this level, that is 2000. This is like light blue. So right now 3 ripples have been generated. So beyond these 3 ripples, the pressure was observed to be 2000 psi. Then comes 1900 psi. Then inside the blue one, dark blue one, that is 1800, and inside dark green, it is showing to be 1700. So 2000 psi, 1900, 1800, 1700. So it is reducing. When time is progressing, these ripples are generating, so that the pressure is also reducing and it is moving forward. Then after some more time, you started to generate a new ripple where this 1900, which is there at a light blue, became yellow. So yellow one created as 1900. Earlier it is where the 1900 that created to be 1800. Before that, which is 1800 was there, that became 1700. And the first ripple which came to 1700 became 1600. So when time progresses, pressure starts to get reduced. Imagine, let us think that this happened with different time levels. I will come from starting itself. So right now time level is 0. At T1, we created 1900 psi at one level. T2, we created two ripples. T3, we created this ripple, and T4, we created this ripple. So when you measure pressure at one location, imagine that I will be giving you one location, that is green one. So at T1, the pressure level is 0. Sorry, at T0, the pressure level at this location is 0. At T1, it became 1900. At T2, the same location, it became 1800. At T3, it became 1700. And T4, it became 1600. So when you keep location constant, when you alter time, pressure is changing. When you keep location constant, that is that green location where we have mentioned here, when you change time, it is not constant, it is like it is altering, it is again and again it is altering. So it started with 2000 psi, which is earlier. After that, at T0, it is 2000 psi. After that, it became 1900 psi. Then became the same location became 1800 psi. After that, it became 1700 psi. After that, it became 1600. If you still more progress, it may go to 1500 psi also. Probably this could be the end of drainage area for the well. So let us think that this is the end of your drainage area. So we could able to create this many ripples. So this, the time taken to travel from green ripple to red ripple is the transient time. When you start producing oil during this time is considered to be unsteady state flow. So this is how unsteady state flow will be understood. So it is like during this particular time, when you progress in time, that fluid flow will change. The pressure for every ripple will change. It looks like water ripples only, how the stone, if you throw a stone in a pond, how the ripples will be generated and it will progress towards the outer boundary of the reservoir. The same way it will, you can contextualize like that over here. So it started with green and it has progressed to dark blue, then light blue, then yellow, and finally the end of the boundary, which is considered to be the red ripple. Okay, beyond that, this is reservoir pressure, that is 2000 psi. In red it is showing to be 1900, in yellow it is showing to be 1800, and light blue is showing to be 1700, and dark blue it is showing to be 1600, and the green one, which was the first generated, to be 1500. So you can able to expect right now the flow is happening from 2000 psi to 1500 psi. So with this pressure difference, flow is happening from outer boundary to the well. So you can able to expect good amount of flow. Why? Because the pressure disturbance started to influence until the end of the drainage area. So flow is happening with this pressure disturbance. So this is how unsteady state flow will be maintained. Once after reaching the end of drainage area, then there won't be change in this ripples. There won't be any new ripple. These ripples, how many have been generated, that will stay static. Why? Because right now water drive mechanism comes into picture where it is holding that ripples to stay static. Because of that, these ripples will be staying static. It will not, the reservoir pressure also will not, this 2000 psi will not go down, because if it is not going down, then the red ripple pressure, which is 1900, that will not go down, and the yellow ripple, which is 1800, that will not go down, and the blue one, which is 1700, that will not go, like that it will continue. So with this pressure difference from 2000 psi to 1500 psi, flow will happen during steady state flow. This is what we will be observing at steady state flow. I told you the change in pressure with respect to time is 0. 0 represents pressure is constant. The pressure will not change even though you progress in time. You reach it to time level 5 to create that red ripple. Beyond that, T6 is there, T7 is there, T8 is there. Like 1 hour, 1 hour, 1 hour, if you add it up, you cannot able to see any change in these pressures. These pressures will be remained constant. There won't be any reduction. Wherever you measure pressure at T6, it is showing the same. At T7 also the same. T8 is also the same. If T6, if you observe, inside the red ripple is 1900, and T7 also will show 1900, T8 also will show 1900, and like that. If you go until which time it is showing 1900, the same time pressure at that any time level, that is considered to be steady state flow. So that also will continue for some time, which is the least time level we will be expecting. After that, we will start to witness reduction of reservoir pressure. So this 2000 psi, after completing the steady state flow, you can witness it will start to reduce. This 2000 psi will become 1990. This 1900 will become 1800, and this yellow one, which is 1800, will become 1700, and the blue one, which you are witness to be 1700, will become 0. Like after steady state flow, it will start to reduce. I will put another diagram which can be understood very clearly. So this is steady state flow where I have explained you. You can able to see the same example. Well is there, perforations are there, different ripples have been generated with different colors. So you can see the drainage area near to the reservoir boundary, the pressure was given to be 2000 psi, and before that it is 1990 red one, and 1980 pink one, and after that 1970 and 1960. So when we are talking about steady state flow, if you change time, let us imagine that after 1 hour, this is after unsteady state flow. We are calculating this. Why? Because unsteady state flow, this pressure ripple started. It started with 1990 at this location, and it progressed until to reach the outer boundary of the drainage area. So that already happened in unsteady state flow. Next comes steady state flow. So after unsteady state flow, if you move 1 hour forward, 1 hour forward, then you can able to observe these pressure changes will be there: 1960, 1970, 1980, 1990, 2000. So when you move even after 8 hours, there won't be change in these pressures. 1960, in that location it is 1960, in the same location it is 1970, 1980 in that location. So like that it will continue. When you go to 10th hour also, you are observing the same pressures. So when you change time, pressures are not changing, means like pressure is considered to be constant here when you change time. So change in pressure when you change time. Why? Because pressure is considered to be constant. So dou by dou t of constant, which is pressure, that can be given as 0. This is how steady state flow is measured. When it comes to pseudo steady state flow, which is the last one, you can able to witness the change over here. At first hour, you observe to be the same: 1960, 1970, 1980, 1990, 2000. But when it comes to second hour, it has reduced to 1950. So 1970, the same location, it reduced to 1960. So 1980 became 1970. Like that, 10 psi it started to reduce. In the same way, if you go to third hour, 1950 became 1940. So 1960, which is on the yellow one, has become 1950. Like that, every time makes these pressures to reduce 10 psi in a constant way. So the pressure reduction is observed to be constant when you change time. That is like dou p by dou t is observed to be constant. Declination of pressure is happening. Even this is not only happening inside the well, but it is happening around the well. That is like reservoir pressure is also reducing. Reservoir pressure is also reducing. Okay. So let us go into the next topic, that is pressure buildup test. This is one among the important testing techniques will be done during well testing. So what are the applications of this test? Pressure buildup is like reservoir permeability. You can able to estimate reservoir permeability, skin factor, faults, interference, limits of the reservoir. So this test will be particularly done during well testing. So how reservoir permeability will be estimated? So there is a formula to find out that one. And how skin is nothing but it is the damage around the well. So with workover operations or any kind of cementation techniques during casing or during well logging, whatever drilling fluids you are intruding inside your well, it will start to stuck near to the surface of the well. So that will damage the permeability of that particular area, and that is considered to be skin. So then when it comes to fault, it's a geological structure which can constrict the flow of a fluid that can be identified by this pressure buildup test. When it comes to interference means like if every well will be having a drainage area. So each well will be having a drainage area. So drainage, if you start drilling a well near to each other, these drainage areas will start to interfere. So that cannot be identified, but we will be witnessing that the drainage area is showing to be infinite. So we cannot able to finite that particular drainage area. Why? Because it is interfering with another drainage area. That also can be identified by pressure buildup test. And limits of the reservoir. So you can able to, so pressure buildup test will help you to understand how much a reservoir have been extended in three-dimensional way, like XYZ axis. So this is not happening every time, but sometimes if the reservoir is not that big, or else like if it is having any constrictions nearby, that can be identified by pressure buildup test. So how this pressure buildup test will be carried on? So first of all, let us take two graphs, which is like Q versus time and P versus time. Like Q represents flow rate and T represents time. At the same time, parallelly, we are calculating pressure with respect to time. So uh, these measurements will be done parallelly. Initially, before conducting this pressure buildup test, your well has to be produced for some time. So your well have produced so that the pressure started to decline. Earlier, the pressure is equivalent to reservoir pressure. So once the well starts to get produced, the pressure starts to decline until it reaches to the minimum pressure, where beyond that it cannot able to produce any amount of oil. So until it reaches to that pressure, you can witness some amount of flow rate, that is this positive anomaly over here. So on the Q, it is showing positive. On the P versus time graph, it is showing that the pressure is declining. Why? Because it has declined to this level where after this, there is no production. So you need to shut the well, you need to close the well. So once you close the well, you will expect that the pressure which have been declined will start to rise up. It will build up. While building up, there will be some changes. Ideally, if you produce for some time, then if you start building up, if you close the well, then pressure will be building up in a linear way. This is the graph which is showing to be ideal. There won't be any changes over here, so it is showing to be linearly, it is hiking up. So once you close the well, pressure will rise up, but not the flow rate. Why? Because you are not producing oil into the well, so that the flow rate is observed to be zero. So flow rate is observed to be zero. Why? Because this is the time, you can take it as delta T, which is shut in time, that can be observed where the flow rate is not available. Why? Because you are not producing any amount of oil. Right now, the condition is shut-in condition. During shut-in condition or else closed condition, pressure starts to rise up. It will rise up until it reaches to maximum pressure. That maximum pressure is nothing but it is equivalent to reservoir pressure. Probably it is equivalent to reservoir pressure or initial pressure. So the pressure where it has declined before shut-in, it will start from that, and until it reaches to the maximum pressure, the pressure starts to rise up. So this is what exactly the process of conducting pressure build-up test. In while building up, you can observe that the flow rate will be zero. So in real time, if you could take some points from a well, so the build-up pressure can be observed like this. You can observe there is a deviation before it reaches to become linear. So here you can observe that the linearity have been continued, but before that you can observe that it is deviated. This deviation happens only because of if the well have been affected by skin. I mean, like wellbore damage or skin might have affected near to the well. So this will impact the rise of pressure. Why? Because skin means the damage which have happened around the well will not allow pressure to rise linearly. It may take some kind of deviations, and finally it will take some time to cross the skin level zone. Then after that it will catch that linear position. So to calculate pressure by using this particular rise up can be magnified to be y is equal to mx plus c, where y is represented to be flowing bottom hole pressure, and x-axis will be given as Tp plus del T by T. So Tp, which is produced time, delta T is the shut-in time, and the slope is given as minus m. So when you when you magnify this with Darcy's law, you can able to calculate this equation, like PWS, which is represented to be flowing bottom hole pressure. Pi represents, this is an intercept of y-axis. So where it is connecting to the intercept, you can see it is touching here on the y-axis. This is the maximum pressure, initial pressure. This could be the maximum. Beyond that, it may not rise up. So this is the pressure. You can see this y-intercept that can be considered to be reservoir pressure minus m. M is nothing but slope of this particular line can be equated to be 162.6 Q naught mu B by KH. So Q naught represents flow rate of oil, mu viscosity, B formation volume factor, K represents permeability, and H represents thickness. And finally, X, M into X, log TP plus del T by T. As I said, TP is production time and delta T is shut-in time. So if you could know about these values, if you plot a graph, it is showing to be a linear hike, but before that you can see some kind of deviations. Okay, so in that way you can able to magnify this line to become y is equal to mx plus c. If you want to calculate permeability, if you know the slope from this graph, m can be equated to this equation so that you can able to find out permeability k. If you have other values like q naught, b naught, mu naught, and h, if you have these values and m from graph, you can able to calculate k. If you have to calculate, this is like permeability. You are estimating permeability with the help of this graph. If you have to estimate skin factor, this is the formula 1.151 into P at 1R minus PWF at delta T is equal to 0 by M minus log K by phi represents porosity, mu represents viscosity, CT represents total compressibility, RW represents wellbore radius. So I will be explaining you what is PR, what is PWF. M was already, we are going to get M from this graph. But why we are calculating skin factor at pressure at 1R and flowing bottom hole pressure at a delta T is equal to 0. First of all, I will be explaining you why we are going to measure pressure at 1R. So immediately after shutting the well, pressure starts to rise up. This pressure will start to rise up by the movement of fluid, where the fluid starts to move towards your well. Once the fluid starts to move from reservoir towards your well, it will start influencing skin zone, which is near to the wellbore. So this will take around 1 hour. So fluids will start to move until it reaches the well. There is a barrier is there, that is your skin zone. So it has to bypass that skin zone. So while bypassing that, pressure will not rise linearly. Why? Because of the skin zone, it may rise in a deviated way. That is how this effect of deviation is happening. It could be skin or else wellbore damage. So this is the one which is there in between well as well as reservoir. So there is a zone is there which have been damaged. So the fluid which is flowing towards the well have been constricted by this barrier. So it has to bypass this barrier. That could take around 1 hour. So initial 1 hour is the time where the fluid is bypassing through this skin zone. Because of that, there is a deviation in hike. It is not linearly it is hiking, but it is hiking in a curved way. It is hiking in a deviated way. So until you reach 1 hour, once you reached 1 hour means all the fluids which have been passed through the skin zone, right now they all reach to perforations. Once these fluids reaches to perforations, then it will build up gradually. So this building of accumulation of fluid is happening gradually. Because of that, the pressure also will be building up in a linear way. Until 1 hour, it will be in a deviated way. Why? Because of this skin zone. Once after 1 hour, it will go in a linear way. So this is how it will happen. That is the reason the ideally P pressure at 1 hour is considered to be the effect of skin. The effect of skin will be observed until 1 hour, not beyond 1 hour, but you can take it before 1 hour. Why? Because before 1 hour, until the 0th hour to 1 hour, the effect of skin is happening. After reaching 1 hour, beyond 1 hour, you are not seeing the effect of skin. It is going in a gradual direction, like it is going in a gradual way, so that you can see a linear hike. But before that, you can see a deviation. Why? Because of skin effect. Minus PWF delta T is equal to 0. So that represents delta T is equal to 0 means before shut-in time, the pressure is observed to be the minimum pressure. Before shut-in time, the pressure was observed to be the minimum one. So the minimum and the 1 hour pressure, it will give you the difference between the minimum and 1 hour pressure will give you the pressure difference which have happened during skin effect. So because of that, these two pressures are considered, P at 1R and PWF at a delta T is equal to 0. And remaining things, if K was known through slope, you can incorporate K here, porosity you can put it and other values so that you can able to calculate skin zone. Then let us talk about relative permeability. We have discussed about these earlier. What is effective permeability, what is absolute permeability. Once again, I will refresh. What is effective permeability? It is the permeability of a rock where it will allow one fluid to flow in presence of another. That is effective permeability. Absolute permeability, it is the ability of a rock to flow only one fluid which is having 100% saturation. When it comes to relative permeability, it is the ratio between effective to absolute. So here what I want to discuss is I want to compare wettability with relative permeability. Right now, by observing relative permeability graphs, how you can able to define wettability. Whether the reservoir rock, we already discussed in earlier session, we have three types of wettabilities. One is water wet, oil wet, and intermediate wet. So these three can be identified by relative permeability graphs. First of all, for water wet, connate water saturation will be higher. So in relative permeability graphs, we have to observe where connate water saturation is. Then when it comes to oil wet, critical oil saturation or else irreducible oil saturation will be higher. So where that is that we have to found out in relative permeability graphs. So if you could observe over here, we have two different permeabilities. One is KRO and KRW. KRO represents relative permeability of oil and KRW represents relative permeability of water. See, here it is irreducible or residual oil saturation. So you can observe over here. And here it is SWI. So we have to see how much percentage of SWI is present, how much percentage of SOR is present. If SWI is more than SOR, then you can able to identify that particular reservoir to be water wet. If SOR is more than SWI, then that will be giving you oil wet. If both are committing to be equal, if they are coming nearby values, then that can be equivalent to intermediate wet. So if you could observe here, there are like two reservoirs for oil wet and water wet. We have two different relative permeabilities. So imagine there is one more identity for this observation. Blue one represents water relative permeability, green one represents oil permeability. So when it comes to oil wet reservoir rock, you can observe that a blue line is showing to be maximum. You can observe big amount of blue line have been observed over here compared to the green one. When it comes to water wet, blue line is observed to be the minimum one. When it comes to green one, it is showing to be maximum. Means when you could observe the movement of a fluid which is showing maximum, that is how it will be observed that that is having wettability towards that particular fluid. Imagine in the first case, you can observe that the water relative permeability was observed to be maximum compared to oil permeability. That means this reservoir rock is allowing water to move rather than oil. Why? Because oil will not be moved, so that the movement of oil is slow. So in that way, you can observe that green line is observed to be minimum. Why? Because the movement is slow. The reservoir is not allowing oil to move fastly or else like leisurely like water. But when it comes to water, you can observe the relative permeability was observed to be maximum. This shows that the movement of water is happening faster inside that reservoir. So that will give you an identity that the reservoir rock is wetting oil, allowing water to move. So in that way, you can confirm that reservoir rock to be oil wet. When it comes to other end, if you could observe over here, the movement of water was observed to be low. That blue line is showing to be low, and the green one is showing to be having to be the maximum value. Why? Because in this reservoir rock, this rock is allowing oil to move, but not water. Water started to get absorbed. Because of that, the movement of water is less. So that you cannot see the hike of blue line. Compared to this, you can see the hike of oil. That means what? It is allowing oil to move further than water. So this indicates that the reservoir rock is wetted. Why? Because it is absorbing water. It is not allowing water to move, but it is allowing the other fluid, which is oil, that can be moved. In that way, you can identify what is oil wet and what is water wet. So we have different cases over here. If you could observe on the first case, the water one is showing to be the less movement. You can observe the water graph was observed to be low and the oil was observed to be maximum. That represents this reservoir rock is wetted by water. Why? Because the water movement is low, oil movement is high. When it comes to the second one, in the same way, it is showing water is showing to be less and oil which is on the red one, it is showing to be more. Water is blue and oil one is observed to be more. This represents this is also water wet. Why? Because the movement that you can see the hike of water is very low. But when it comes to hike of oil, it is showing to be very high. When it comes to the second one, both are observed to be on a constant way. Both are moving towards here. If you could observe, SOR as well as SCW are moving to maximum. At the same time, both are showing to be reaching to maximum height. That represents this reservoir could be having a wettable capacity of both. Like it is intermediate wet, like it is wetting either oil as well as with water. When it comes to the last one, that blue one is observed to be little less compared to the yellow one, sorry, red one, which is represented to be oil. So here the oil was observed to go in a hyper way rather than water. In that way, we can take this reservoir rock to be on oil wet side, but mostly towards intermediate wet side. Why? Because both are showing to have the movement. Both are having relative permeabilities, which is showing high. It is not exactly oil wet or water wet. It can be taken as intermediate wet. Why? Because both are on the above cases. You can see water was observed to be very low. So this is not having y-axis. Maximum amount of y-axis was not observed on the two cases. In that way, you can take this to be oil wet. But here, both are having y-axis. Water is having y-axis. In that way, you can take both to be intermediate wet. It cannot be pure oil wet, but it can be intermediate wet. So up to here is the session. I hope I have covered some important concepts of reservoir